No, welcome back. So we continue with the mixing element case, and let's go to the default mesh. Okay, the default parameters. This is what we have. But now we're going to play with the boundary layer. Okay, we have it. It works, but what we want to do is make it much, much, much finer. Okay, so make it work. So one thing that I want to point out, or to revisit, remember three-step castellation. The next one, it is snapping, and this is snapping. In theory, as you look at here, due to curvature, we talk about this, you should have here everything is uniform. Here also should be uniform, but due to the snapping process, okay, numerical precision, whatever the algorithm implemented, you will get that perfect snapping, and this will change your aspect ratio, which in theory here should be 1. Here also should be 1, but we see that it's not anymore 1, and look at that here, it's still collapsing. And there is likely you will have problems with the boundary layer that is strongly depends in the aspect ratio. Okay. So let's revisit generate to show you to generate boundary layer different technique, different boundary layers to show you how I do it. But again, at this point, you have a clear idea how things works. Want to point out here also there is a nice discussion, okay, in the notes aspect ratio. So probably this one also can clear your mind, clarify many doubts, but basically, this ratio maximum, minimum, okay? It can be in any direction. Usually I like to take the diagonal, okay? I like to be more conservative. But in any case, I want to discuss more of that. So here I have the mesh, and one thing that, let me run checkMesh. You run checkMesh in each step, you're going to get the mesh quality. And look at that. Let's focus on mesh and orthogonality. First one, the Cartesian mesh. That should be 1. Look at it here. It's 1.16, close to 1. You know that in the transition between different cells, it will add different shades. So that's why it's not, but it's close to 1, and this is what we want. If we get to the snapping step and we have this one, it's almost certainly sure that your boundary layer, you're going to get a good one. But that is not the case. Here we get something about 5. So basically this is telling you already that you divide by 5 your, so let me go to the figure. So basically is you're going to get some cells. Notice you get this L mass divided by 5, and you're going to get some cells about that dimension. Okay, it's not very uniform. So this would be a problem. In my personal experience, up to 3, it is okay. You know that it's very safe, your boundary layer. More than 3, up to 6 or 8, still you can apply some tricks. More than 8 or 10, it's better to redo your mesh. And redo I mean adding more refinement at the surface. That will be your solution, okay, to get everything uniform. And then from here we move to the boundary layer, and in the boundary layer, look at how it changed. Now it becomes maximum 6, which is okay. Okay, there is no problem. This is perfect. I have no problems that here, but what we want to do here is now, let's make it much, much finer. So I have my dictionaries here. Let's take the starting case boundary layer. So let me redo here. Okay, I have this step here. So let me do something. I want to redo boundary layer, and let me erase. So let me go here for phone list times minus rn, erase minus processor, and minus time 3. So erase time 3. So just to be sure. So okay, I erased the time 3, and now I can redo my boundary layer. So basically have this dictionary. So default was 10, was 5. So when the default dictionary thing, I think it was 5 or 3. I don't recall. Let's see here. How many inflation layers do we have? Okay, 5. Now let's go to 10. Okay, so we know that the background, so here I go back to my Excel, my background is 0.2, I have a 2. So if I go to 10, I should have near wall distance, something like this. Hopefully, Okay, it's not uniform, my refinement ratio, because also in the surface I have 3. Okay, I think I have, yeah, pi small, so I should use 3 as well to check. But let's take a look what we have. Okay, let me redo that. Let me see if I already have it here. Okay, probably here. I should have that command here. Bam, 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 bam. Okay, I have my checkMesh. Checkmate. Okay, so see here that run snappy, do just the BL, the last step, and let's see what we have now with 10. So remember, always have my advice. So see what with 10, as predicted here, it will work. Okay, for me, I have no problem. I have this aspect ratio. So you see that aspect ratio is a very important field. So actually, I think it can be, I know that in the ESI version, .conf, it can be saved. There is a function object. I don't recall if in the foundation version can be saved, should be possible to save, should be the functional object. In any case, you can program. But well, I already get my estimate, so I don't like to look that opening up out of you can consume some time. But if you want, you can save that information because, as you can see, it's very helpful for boundary layer. So if I go here, let me go top. Remember, always check this one. So here we have our estimate. So we have two different pipe small different. For 11. Okay, so I should use that one trick here. Okay, so 10 layers. Okay, this is what we have. Okay, 0.11. Okay, so yeah, something about that for the pi. So this is the one we should take into account about largest here, but you get the point. So here it is okay, but now let me go to 20. 20, according to this here, should be marginal. Okay, I already passing the 32, but still my boundary, my aspect ratio is a sector. But let's see what happens if I go to 20. Okay, and still in 20, it will be something about, okay. So look at that here, we're arriving now to this aspect ratio, to this limit of 0.0001. Okay, that you have the note here. Okay, so basically you have that limit here, usually meaning that if you have a unique cell, you will get something about 10,000 or the aspect rate, you know. Anyway, so 20, let me go 20. So I was BL here, so let's increase this one to 20. So we have expansion ratio 1.205, the standard values, I haven't changed anything. So let's see what happens here. So let me erase again. Okay, for list times minus RM minus processor minus time 3. Okay, let me be sure that sometimes. Okay, I erased it. Let me restart the boundary layer now with 20. And this is what we have. So with 20, we should get something about, okay, 3, okay, 0. Okay, so here a small difference. Let me see what is the problem. Okay, probably we have different values. Okay, but look at the coverage that we have. We didn't cover everything. Let me check here what we have. Snappy bevel. Okay, I have bam, 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 bam. 3, 4 there, 2, 2 surface by small, 2, 2, 2. Okay, I think I should be using 2. I use 2 here. 0.2, 20. Okay, yeah, that sounds, yeah, that it was 2, yeah. So having there, yeah, it sounds about right. Okay, so clearly also you can see that it's much better to have uniform all the surface. But something about this, so already I hit the 100 there. I know it's not going to work. Also the 32 here that I mentioned. Okay, also you hit it there. But this doesn't mean that this mesh is not going to work. Okay, so it failed or you have something. And nevertheless, you also can check here the aspect ratio, because it generated some cells, but let's see what aspect ratio we have in those cells that it managed to generate. So let me go here, 3. So basically went to an aspect ratio of 67, okay? But let's do something. So how can I get this mesh? So first, also let me visualize, because there's another problem, okay, that we already visited the problem, but just to bring it that concept back, it is this one, these cells here. So usually it is strongly recommended to have a uniform. This transition can give you problems when you are growing the inflation, in particular with uh, this kind of meshes, with internal flows. And clearly you see the problem here. You are too close, you are pushing away. So you have those problems. So let's do something, okay? Let me put there a uniform transition. So let me go here and put here 3. So now everything is uniform. Likely it is going to work better. So let me go run mesh parallel. So I will redo Cartesian and snapping meshes, okay? And then we have the same parameters here. I'm not going to change something, and we're going to see that it's going to improve a lot. Okay, so I forgot to disable that option, so it's going to do here, and should be ready soon. So as I say, just always check here. I'm probably now I'm quite sure you have a better idea what those quality metrics are doing. And there you go. So now, okay, well, we were still using the old one, but let me erase here, bam, 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 bam. Erase this one, and let me redo the boundary layer. This one. Set. Way faster, everything seems okay. And look at what we have. Recall the previous case with this exactly the same parameters that we had a lot of problems. Always remember, visualize your mesh, but we already immediately can we see the difference. And bringing this concept back, remember, try to have uniform meshes, and clearly we can see it here in this case. This is particularly important when you have internal flows. Okay, so see that how things change when you manage to get everything uniform here. Okay, you don't have any more of the problems that you were having there. So this is the first way to resolve problems. Okay, try to control that transition. Previous case, you have that transition, it wasn't good internal flow. External aerodynamics, same stuff will happen, but it's much easier to control there, so it's not such a big problem. But when you have faces that are opposing, two faces that are opposed to each other, that might give you problems growing the boundary layer in external aerodynamics. So have all that. So for instance, if you do this external aerodynamics, these two faces are going to give you problems. So you have to keep that in mind. So let's redo this mesh. So this is a perfect mesh, and let me look. I don't recall. Okay, let's see the first cell center. I don't recall what was the near wall distance. Good. Let me let me interrogate this file. Okay, you have near wall distance. Bah, I guess. Let's do something. So, bam, bam, bam. Let me erase for time step 3, and let's redo here. So let me go. So we have here this one. So we have this parameter. So now let me increase the number. Okay, let me put here 30. Okay, let me go to 30. So using this now here we go to 3. This should be 3, 30. We should, wow, this is very, very low value that we're aiming, and for sure it will fail. Ah, by the way, probably also I think I saw this should be 1.2. Okay, that was the difference in the previous case. So now we have the right distance. But any case, 30 still is a low value. So let's go here and let's do this with 30. We have standard dictionary, all the standard metrics, and 100% sure that it will fail. And this is difficult to control in this case. So see that we get something, the boundary layer grow in this specific patch. We can do a checkMesh. Okay, I just want to see the aspect ratio. In that apparently it, 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 you have some coverage, but your aspect ratio to see that 96, now very close to that maximum value that I defined, that is 100, that start to be problematic. But any case, remember that during the process of doing the boundary layer, it's always checking quality metrics. So that is why you have the collapsing, or it is enforcing those quality metrics. Okay, but let's disable those quality metrics, and I want to see a boundary layer. Don't check that. I know that what I'm going to get in the output is not a good mesh, but at least I'm going to get something will grow, and I would like to see what happens with my aspect ratio and so on. So we do the same, okay? So here, and let me run here. The only modification, I disable this iteration. These are the iterations not in the boundary layer, that is doing another iteration, check all quality metrics, try to enforce everything, try to get a good aspect ratio, an ideal one. So see that now by disable that, I have something almost whole coverage. This is no good, and I know that if I go here, check mesh, I want to check that one, I'm going to see all the errors, many errors. So see that I can see the aspect ratio, and already aspect ratio, so I can see that something went to zero. So I have zero volume cells. Okay, so this is a problem. Okay, and then you have some other stuff. All this error is just because it wasn't controlling the quality. Okay, so I identify something. Okay, let me go here and let's try to generate something. Let me put this one. So we have seen that this one usually is related. Most of the time that one is related to boundary layer. So let's put that negative. It will disable those quality checks, but it will, the solver, the snappy will do all the iterations, it will check all quality metrics except this one. So now likely orthogonality, skewness, and so on will be okay. And see that we have a okay mesh. My check mesh here. And there you go. Problem solved by just putting that. And let me see here. No orthogonality 74. Okay. Just no orthogonal face. Just much better than I was expecting. Okay. And let me go here. That see that now we have very fine meshes. And following the same technique, you can go to 10 to the minus 6, okay? Probably you're doing naval applications. Those are the values that if you want to go word resolving. Most of the cases, I stay between 10 to the minus 4 or 5, so I can control. 10 to the minus 4, it is very easy to control. 10 to the minus 5, districts. 10 to the minus 6, it is a little bit trickier because 10 to the minus 6, to get to those values, you get the point now. It is everything is aspect ratio. So if you go 10 to the minus 6, you also need to refine your surface. It is extremely difficult to get in the within the same aspect ratio to those values. So for instance, if I want to go 10 to the minus 6, let me go here 4. A refinement of 4, and we reduce there. And you will see that as you put 6, it keeps going lower. Okay, so see, but this is very, very high values. You go 8, okay, you get there, but a value of 8 is a lot. So remember the technique that I show in the airfoil case, that you can refine some specific region. Okay, I'm not going to do it. Okay, but in this case, for instance, we can go, I will redo it with a refinement of 4. Okay, we put a 4, Now 30, we can go lower there, and I can go here 125, and see that we start to enter there 1.3. Where, okay, actually I think we don't need that 3. Okay, see that we go to the -6. So let me increase just the aspect ratio, the growth rate here. Here is telling me you are way, 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 way out of your permissible limit in aspect ratio, but by disabling that quality metric, it will work, okay? So these two quality metrics, just to stress here, that you have 32 and 100, are related to having aspect ratio in the snapping close to 1, 2, 3. So you have that one. This is how OpenFOAM does. Now doing some debugging, that is the logic and how everything is done. Then the meshing is, you don't get there, you have all those cool corrections that you see there, curvature corrections and so. So in any case, let me enable this one. And yeah, we have it there. Okay, now I need to change here the boundary layer. I'm not sure if this is going to work. Probably I'm pushing too much. I think it would be better to add another refinement for, but let's see, that will be the step. So let me go here, erase this one, put it there, and set that here, the predicted value. Okay, we're getting there, and it will start to do all its magic. Okay, and this is now that again to stress. So see that it's better, but it still is not perfect. But what I want to know, let me copy this one. This is how it works. It works always save the iteration 1, 2, 3, and you have seen that even the first iteration, the castellation, it's important to save, control that everything is okay, all the region, check the aspect ratio should be close to 1, not necessarily will be 1 because you have transition. But if in that step you see aspect ratio of 2, that might be a problem. When you're happy with that, pass with snapping and start to check aspect ratio, so on. So up to 3 is okay, more than 3, maybe you can change something, more refinement here and there. But those are my techniques, okay? Most of the technique works. You don't need to do many iterations, so just refine a little bit here and there, it will work. And then the boundary layer, what we're doing now. So I'm saving for this specific case. So here, to mention, we disabled some quality metrics, and you get this one, so some coverage. And let me run the checkMesh here. So see that it's telling me everything is okay, 10 orthogonal. So an aspect ratio, maximum aspect ratio, that 74. Okay, so here it is very different from what I have here. That for me 4,000, because here it is no, it is adding some it's moving some cells, some nodes, it's doing some smoothing in the cells just to fulfill the quality criteria. In my Excel, I don't fulfill those. This is plain. There will be no iteration nonsense. So if you disable the iterations, probably you will get the infinite value or value super large. But what I want to say here is that let's redo exactly this one, but let me redo this mesh. Let me disable here that I want to save this step. And let me increase the refinement. Okay, so let me command this one. So I don't want this. Let me go all over 4. Okay, and leave that 3. So you have transition with it. So let's redo this mesh. So this will be time consuming, but let's see what happens. Exactly the same parameters, a finer surface mesh. What will happen with these values that we have, the thickness there. So, okay, I have a problem. What was the problem? Bam, 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 bam. Okay, probably. Okay, okay. Let me go. Let me see what was. Okay, let me go there. It's working, so probably miss something somewhere. Okay, probably was this. Okay, let me come. Okay, I don't want this. I want here 4. 4 and 4. So it should work. And then inside is 3. Okay, working. So let's wait a little bit because I think this will be time consuming. Okay, so we have a mesh. Let's see the quality metrics here. So look at that in this one. We have 513. Okay, I think it's the same as the previous one. But what we want to do now is add exactly the same mesh at the boundary layer here. So now we have much smaller, meaning the large edge. So go now I make it smaller. So my aspect ratio, if I keep this distance, my aspect ratio should be much better. Which, by the way, L mean the distance normal didn't keep is smaller, but you're reducing distance. So let's see what happens. Okay, so you see that it's doing more iterations. So bam, bam, bam. Getting there. So the culprit we start to see that is this face with. So this is at the surface. I immediately know that that is highly related to the surface. Here is okay. So each of these iterations, what it's doing is smoothing the mesh, now doing some operations just to fulfill these requirements. So in doing so, you may have that collapsing that you commonly see. So let's wait a little bit to get our final mesh. Okay, so we have our final mesh. As expected, it's something better quality. Didn't improve that much, but it's much better quality. Let me go here also check mesh. So here you see that finer meshes usually will improve your boundary layer. And the final step here, okay, I have that one disabled there. So now, well, excuseness, this for me is not a big issue. Orthogonality is not it's not a big issue. And now if we check aspect ratio, is lower. I recall it was 96 previously or something about the same value. So this is it now, how we control. So now we have a much finer. So we went down to 10 to the minus 6, if I would recall now. So let me revisit here what was. So much finer. And again, so you're not happy with that, refine a little bit the mesh, but already I need a limit for me. Okay, so see that this is quite a low value. Okay, for me already 4 refinement factors. Now when I do the mesh, putting 4 for me is almost in the limit. For me, the maximum is 5. At this point, I would prefer to get a background mesh with local refinement around the body, and then this one I will keep it about 2. Well, in this case, get a finer blockMesh. BlockMesh here, instead of 0.2, 0.1. And likely you will reduce all the memory usage, all this stuff, and it will work better. But yeah, there you go. You have all these tricks to generate your mesh. Okay, at this point, let's visualize. Okay, so phone built in. Can never believe what checkMesh is studying. Sometimes it is far from reality. So let's see here what we have. And probably by getting a visual reference, we might know where to improve or where to add another refinement. Okay, so this is what we have. Okay, this is quite funny. Okay, let me see. Okay, so this is not ideal at all. Okay, so what happened here? You have this here, look at here. So this is not ideal at all. So that might be. Okay, so in this case, now the culprit I mentioned, I forgot when I was setting the dictionary, see the input. I'm using now, and let me go back here. an expansion ratio, growth rate of 1.3. Okay, that it will let you reach lowest value here, but it will arise some other problems as you see here. So as you can see, this is a gain of numbers. No, you can change a lot of parameters. This specific case 1.3 it will work, but you need to increase your surface refinement. If I will recall, I arrived to a surface refinement of 5, which is a lot, but you need more memory. No, so in the computer I'm running I have only 24 gigs, and it used more memory. As you can see now, this Snap is very, very memory eager. And just to show you, the differences here, for instance, this is this is what is reporting. No? So we have a uniform mesh, so we mesh very well by using 1.3, which but is too much, it gives you that problems. You go, for instance, you increase it to 1.5, you can reach even a lower value. I don't know, for what y plus value you will use this, but you can reach, tricky to get. But let's go back to the original one, 1.2, probably 1.22 still in this case it will work, but 1.2. So the other way that you can control this is by changing this value percentage of the final cell. So if you go to 40, see that you are reducing. So probably value here, personal experience, I have been able to use up to 5. So look at that, you go here. I don't recall if it will water, probably will give you some issues, but the main issue here will be you need a better surface refinement. So 4 is not enough. Probably a value 5 will improve, but see that we keep 1.2 here, and maybe you can go to 20 here. No, 20, so 10, it will go to something now in the order of 10 to the minus 6, which is already something very, very fine. And yeah, this is it. Now there are all the parameters how you can control. So just to remind you here that I left this value 1.2. You can go here 0.2, erase, try to redo, and get look at the solution. My advice will be also to increase the surface refinement. Also have in mind memory usage. So likely you will need to increase this because now you start to see now that you're adding much more layers, refinement. Also you add another refinement layer, another refinement level in your surface. You go from 4.4 to 5.5. You will see that since start to become really, really expensive. So I think this is all for this video. We cover a lot. We managed to get 5 measures. We can go up to the power of -5, as I say. It's quite easy to control. -6 get a little bit trickier, but because it depends more in the surface refinement, and then the gain of numbers, how you combine these different parameters and so on. Okay. And well, this is it. We have covered a lot. You have all my tricks, then you will have new additions, new videos. This one, there are some other geometries that probably later we're going to revisit, but it's the same idea. The problem with the normals and so on. So later we'll revisit that, but it will be quite fast. So yeah, I think this is all for this case. We generate the geometry, we did some post-processing, different techniques, then we run the case, and then we took the geometry, we look at some parameters, changing something here and there, curvature and so on. We look at the aspect ratio, and then we went into the boundary layer, try to get some finer boundary layers and so on. So that's all. Thank you for your attention. See you next time. And I hope you're enjoying this meshing training. So thank you for your attention. See you next time.